So this first problem and the second problem, all we're doing is factoring. Once we factor it, we are reducing it. Okay. So you have to know your 5-step method. We've worked on that in here. I'm sure a lot of you have forgotten it. Well, relearn it. Okay. It's going to be huge. 5-step method always starts with GCF. Okay. The GCF means the greatest common factor. So I like to do the greatest common factor with the upside down division. But when we deal with these, we tend to use upside down division and right side up division. So, and I can go backwards division. I can go like this. If there's not enough room over here, I just go backwards. Okay? So we've already learned how to do upside down. We know regular division. Why not go backwards? Right? And all that means is what goes into 4 and 20? 4. How many times?
5.
So 1 and 5, right? So I just broke that up into 2 pieces. Okay? I broke that up into 4 times x plus 5. Right? And it's over. Now, I mean, you can do one of 2 things here. You could try to take out a 4 here if you wanted. Right? Does anyone know how many times 4 goes into 20 or 12? 3, right? So I'm left with an x squared here, right? Okay, so I'm left with 4 times 3x squared. Does everyone see that? Okay. And so the 4's cancel. It's pretty easy, right? It's just division. It's just fractions. And so I'm left with x plus 5 over 3x squared. Now the problem is, I need to know what x cannot be, right? The bottom of this equation cannot go to 0. So I need to start with this piece right here and say 12x squared cannot equal 0. And then I solve. So I divide by 12 and I divide by 12. I get x squared cannot equal 0. Right? And then I take the square root. And I take the square root. And that gets rid of the square, right? So I get x cannot equal 0. Right? So that's pretty simple. Whereas x cannot equal 0. And that's your answer. Okay. Make sure that's recording. Alright. And so how we doing? Pretty simple so far. Nothing like crazy. Okay. You notice I didn't cross out the x with the x because this x is being added. Right? If it was multiplying, then I could cross them out. But when they're being added, I can't just cross them out. Okay? So with this one, I can't just cross an in with the in. I have to factor this. Right? And again, it's 5-step method. The first step is GCF. Right? Greatest common factor. But there is no greatest common factor. 1, 2, and 1. The only thing goes into 1, 2, and 1 is 1, right? Okay, so then I move to the second step. And that's that parentheses star variable. Okay? And the star in this case is a 1. So there's no star, right? And if there's no star, then there's no star cleanup. That means it's really just that 3-step method, right? So the 3-step method is your parentheses, your variable, right? And you bring your first sign up, right? So that's a plus. And this sign tells me that these 2 signs are what? The same or different, right? So they're either the same or they're different. Right? If this is a plus, then they are the same. Sum, same. Right? If it is a minus, then they are different. A difference means they're different. Right? It's a sum, that means these have to be the same, so they're both plus. Okay? And then you have your fourth step, product and sum. Now my product is the first times the last. That's 1 times 1, which is 1. Okay? My sum is the middle number. So I need two numbers that multiply to be 1, but they add to be 2. Two numbers multiply to be 1 and add to be 2. 1 and 1. Right? 1 times 1 is 1. 1 plus 1 is 2. Okay? And then I have it factored. And my factor is n plus 1 times n plus 1 all over n plus 1. And check this out. This cancels with this. Pretty easy, yeah? So my answer is n plus 1. But it doesn't stop there. Because remember, this bottom cannot be 0. So n plus 1 cannot equal 0. Okay? N plus 1 cannot be 0. The bottom of the fraction, even though I got rid of it, I still can't have that bottom be 0 because it started that way. Okay? Alright? So, I just solve. Minus 1. So, n cannot equal negative 1. Pretty simple, yeah? Okay? So, whereas n cannot equal negative 1. And that's it. That's all that's about.